This is the video lesson for translating between graphs. The learning target for this lesson is, I am learning to translate between position time graphs and velocity time graphs and vice versa. The success criteria for this lesson are, I can translate a position time graph to a velocity time graph, and I can translate a velocity time graph to a position time graph. Alright, so the purpose of this lesson is to show how to draw a velocity time graph based on a position time graph and how to draw a position time graph based on a velocity time graph. So the first thing we're going to do is draw a little dotted line down here from the transition points on the position time graph onto the velocity time graph, so we know exactly where our graph transitions. Okay, so I've calculated the slopes on the position time graph, which is what gives us our velocity. So the slope for this part is 1 meter per second. Part for the velocity here is 0 meters per second. And then the velocity here is -1/2 meters per second. So remember, to figure out the velocity of a position time graph, we just calculate the slope. Okay, so the velocity here is 1 meter per second. The velocity for this part from 12 to 16 seconds is 0 meters per second. And then the velocity for 16 to 26 is 1/2 meter per second. And 1/2 meter per second. All right, and then we're just going to join those lines. All right, so that's what that first velocity time graph looks like. So notice that if we have a constant velocity on a position time graph, the lines on the velocity time graph are flat. So that indicates a constant velocity. Flat velocity time graph for a constant velocity. All right, so let's do our second position time graph into a velocity time graph. So same thing, I'm going to draw a dotted line down here to mark our transition points. Okay, so the slope of this first part here is -1/4. So I'm going to draw a line at the -1/4 mark to here. So let me write these velocities here. So this is velocity is equal to -1/4 meter per second. For this part right here, it is -1.25. And then again, that's meters per second. For this part here, the velocity is 0 meters per second because we have a flat line on the position time graph. And then for this last part, the velocity is equal to 1.5 meters per second. Okay, so we've drawn our first velocity of -1/4 meters per second. The next part is 1.25 meters per second. So that is down here. That goes to about there. All right, then we have a 0 velocity. And then finally, we have a positive velocity at 1.5 for this last section. All right, and then we're just going to join up all of our sections of the velocity time graph. There we go. All right, and there you have a translation between a position time graph and a velocity time graph. Okay, so here we're going to translate between a velocity time graph and a position time graph. So we're starting with a velocity time graph and ending with a position time graph. So I'm going to start the same way. I'm going to draw a dotted line up from my velocity time graph to my position time graph so that I know where my transition points are. All right, now to start with a velocity time graph, we need to know the initial position x, or the initial position on the y-axis. So we call that x naught, and we're going to start at x equals 1 meter. So we have initial velocity of 1 meter per second. Then we go down to 0 meters per second. And then we go down to negative 0.5 meters per second. Okay, so we're starting at 1 and we're going up 1 meter a second. So we're going to start here at 1, and at 10 we're going to be at 11 on the position time graph. Then we have a 0 velocity, so that is on a position time graph, that means a flat line, so no motion there. And then we have a negative 0.5 meter per second slope. So we're going to start here at 11 on the y-axis, and we're going to go down to 8 and end at 26. So there is our position time graph for this velocity time graph. So we start at 1, go up to 11, so that gives us our 1 meter per second velocity. Then we have a 0 velocity, so 0 meters per second, 1 meter per second, and then negative 0.5 meters per second. All right, and so for our second velocity time graph, I'm just going to translate our change of position here. So this is a little bit simpler velocity time graph. So we start at 10. Our initial position is 10, and we start off with a 1 meter per second slope, a negative 1 meter per second slope. So we start at the 10 meter mark, and we go down to y equals 1. All right, and then we have a vertical, or a positive velocity of 0.5. So we're going to start at y equals 1, x equals 6, and we're going to go up to y equals 14 and x equals 26. So that is right there. So now we have a velocity here of negative 1.5 meters per second, and here our velocity is positive 0.5 meters per second. All right, and that's how you translate from a velocity time graph to a position time graph. One thing you definitely have to start change from a velocity time graph to a position time graph is the initial position. If you don't have that, you don't know where your position time graph starts. All right, everybody, keep asking questions. It's how you learn new things.